Hello, class. This will be the second recorded lecture for section 12.2, and we're talking about hypothesis testing for independence. So the first lecture, we went through some ideas of the definitions, categories, and reviewed the probability definition for independence. So now what we're going to do is to walk through the actual hypothesis testing using those concepts that we talked about previously. So I'm going to go through what the book, and we're going to use the same data set that we talked about in the previous recorded lecture. And so this is hours studied in 3 different categories and 4 different majors. And so we talked about this idea of first setting up the hypothesis. And the null hypothesis will be the majors and the study hours are independent, and the alternative will be they're not independent, or you could use the word dependent as well. And so when you work through this, and we talked about this, we had 6 different steps to do this calculation by hand. And the first is to state the null and alternative hypothesis. So we did that. And so the next step, and we talked about this in the last lecture, is that given the rows and columns, you want to get the totals. So what I have here is I've set up a spreadsheet where I'm going to do all 3 of these calculations. So I already have it kind of organized and to save some time. But first thing we want to do is to walk through each step. So the next step is once you enter the data, and up here is our observed data, right? We'll just do the totals. So again, if you highlight your row or your column, in this case column, and do sum, you see that you'll be able to calculate the sum of the humanities column. And I could cut and paste or copy and paste those formulas to get the total of the social science, the business, and here the engineering. And so to do the rows, you could highlight the row and then go back up here and hit sum, and you get the rows of all 3 of these. So you copy these, and you see there you got the total of the 3 rows. And then to get the total, grand total, as we call it in the book, just do the sum of all, either the total of the column or the total of the row, you'll still get the value of 1,000. And so that is step 2, calculating the rows and columns for those particular data set. So the next thing is this expected value. And you remember from the previous section, we were doing goodness fit tests. We were just calculating those probabilities, right? We were doing that uniform calculation with the days of the week and absences. Here, you have to do a calculation per cell. And so again, as we discussed in the previous lecture, it's the row total times the column total divided by the grand total. That's the expected value. And so if we go to the spreadsheet, I have the expected value spreadsheet set up here. So what I would recommend is copying and pasting the values into another little section here and keep the totals. So what we're going to do now in this calculation is calculate all the E's. And so to do this, let's do cell number, first cell, which is the humanities total, which is 257, times the 0 to 10 hour total, which is 345, divided by 1,000. And so the beauty of the spreadsheet is you could just click on these numbers and it'll do the calculation for you. So I usually do the row first times the column, and then divided by the total. And we did that in the last lecture, and we got 88.665. And you need to do that for every single cell. let me do a couple more for you, just to make sure that everybody knows how to do this. If you're going to use the spreadsheet as your calculator, which I would recommend. So again, you hit the equal sign to start. I always do. So this is the second row. And then we're going to multiply again by the total of the first column. And then you divide by the grand total. And there the expected value is 110.57. And so let me just do one more. Let's do this last one here. So this last one is equal sign to get things started. This is row 3 total times column 4 total divided by the grand total. And so again, you highlight and get that. So I'm going to pause the lecture and finish this up. You don't have to watch me do all these, and I'll be right back. I'm back. So what I did here is finished entering those formulas and got calculations for all the expected values. And so if we go back to our list of steps, that is step 3. Crazy, huh? And so what is step 4? Well, step 4 is choose a significance level and then calculate the statistic. In this case, we're given a significance level of 1% or 0.01 in the original problem. So now we need to calculate this test statistic. This is, again, very tedious, so that's why the spreadsheet helps a lot. And so the strategy is it's going to be the O value observed, so from our first table, minus the expected value, the E, from the second table. We're going to square that and divide by the E value. And so when you do that here, I'll do this right here. This would be equals, and now we need a parentheses because we got a square, and it's O, that would be the 68, minus the E, which would be our 88, and then we're going to square it, and then we're going to divide it by our E again, which you just click on that cell and bring that over again. Oops. Let's try that again. So it'd be equals, it's O minus the expected value squared, and then we're going to divide by E again. I put it on pause there because it looked like I forgot to put my equal sign in there to start the equation. And so let me kind of rewind here. And so this is equals and then parentheses. And then we want 68 minus 88 and some change there, right? And now we'll end the parentheses and square. And now we'll divide by the E value again of 88. There we go. And so we get 4.8 and some change. So you have to do that for all these. The nice thing is that you remember that the ability to be able to copy and paste. So you could copy and paste down here and get all 3 of those values. And you can actually do that for all these. And so let me do all of them except for this last one here. So let me do this last calculation again, just to show you one more time. So you have to put an equal sign, not a plus, but put an equal sign to get started here. And then parentheses. And so this would be the O value, which is 52, minus the E value, which is just 38.9 and some change. Square it, and then you divide again by this E value of 38. Whoops, I forgot my square. I see what I did wrong. Okay, we need a 2 there, and now we hit OK. There we go. And so you can see that we've calculated a bunch of these test statistics. So let's go back to presentation there, and now we calculated all 12 of the O minus E squared divided by E. So this last part is we have to add them all together. Okay, so if we add them all together, Just say like we add this row here, go up and hit sum. And then we could copy and paste these to add the other two rows. And so there we go. And so how do we do all this? We just highlight that and do one more sum. And so our test statistic is 34.63, which is quite big. So we want to compare that to the CHAI statistic that we're going to read out of the table. So how do we get that? Well, those are the next steps. So we look at the next steps, and here's what we have. We have find the critical value from the table. And first we need the degrees of freedom. And so the degrees of freedom are set up where it's degrees of freedom is the row -1 times the column -1. And if you look, we had 3 rows and we had 4 columns. So we had 4 majors and 3 categories. So this would be 3 minus 1 times 4 minus 1, and that would be 2 times 3, which is 6. So our degrees of freedom is 6. And remember, we're looking for an alpha of 1%. So now we want to go back to the table. So let me pull up the table. And you look at the table here, and it's like, okay, so degrees of freedom of 6. And we go over to the 0.01 column, which is second from the bottom. And you can see that's 16.812. So if you look, go back to the whiteboard and let me write that on here, that's 16.812. And if we go back to our original calculation, so we go back to the spreadsheet, you could see that we had 34.6377, which is much greater than 16. So in this case, it's much greater. So now we need to state the conclusion. And so when you do that calculation, again, in the slides here, and then you could see that they got the same number, 16.18. And since the test statistic is greater than what we got out of the table, we reject the null hypothesis, which would imply that they are dependent on one another with regards to hours spent studying and the specific major. So I think you're all probably saying, is there a way to do this with technology? And the answer is yes. And actually the calculator is set up quite nicely on this. The spreadsheet, kind of nicely, but you still need to do a little bit of work by hand. So for those of you that have the calculator, you would go to hypothesis testing and the chi-squared, and then stats and test. And then you want to enter this information in the matrix again. And so when you enter it in the matrix, this idea of entering the observed values would be right here. And the expected values would be the NRA, the values, number of hours spent studying. And so I'm not sure what they mean by this B here. You know what, in class, we'll play with this a little bit and we'll see how it goes. I just went back to the book real quick, and it looks like that this B matrix, which is expected, will be calculated by your calculator, which is nice. That is the advantage in this case, where the spreadsheet, you actually have to do that calculation. And back comes a really small p-value, right? I don't even know what that is. It has 2, 4, 5 zeros, and then a 5. And that's quite a bit less than 0.01. So again, you would reject the null hypothesis. If we go back to the spreadsheet, you would use the chi-square test again. And let me show you how to set that up. The issue is that you need both of these matrices to do that. So you do need to do the expected value matrix And so this would be, again, the chi.square or chi-square.test. And so the actual is the observed. And so we put those in there. And the expected value is here. So we would put those in there and hit OK. And you can see we get that really small value. E to the -6 means you move the decimal point 6 places to the left. So you'll have 5 zeros and then 506. And again, both of those will give you the p-value. And it looks like what's really nice about the calculator, I do have to admit, it also gives you the chi-squared calculation. They have this here. So again, pick your poison. I wouldn't go out and buy a calculator just for this calculation, but it makes it a little bit easier, I think. But this will conclude the second part of the recorded lectures for 12.2, and that ends the introduction to independence testing.